गाइस व्हाट्सअप, क्या हाल चाल, तो कैसे हो आप सब। तो जो हमने फिजिकल वर्ल्ड रीडिंग किया था, तो हमने बहुत मेहनत करके उसका नोट्स तैयार कर लिया है। अब हम उसका नोट्स देखेंगे, तो उसका नोट्स पढ़ेंगे भाई साहब। कम से कम 60 से ज़्यादा पॉइंट है, ठीक है। अगर आप इसको तैयार कर ले रहे हैं तो इससे लगभग 5-6 नंबर तो कन्फर्म है, ठीक है। तो पहला चैप्टर है फिजिकल वर्ल्ड, ठीक है। उसका हम नोट्स, चलो देखते हैं, ठीक है। उसका नोट्स हम तैयार कर लिए हैं, चलो देखते हैं। हम रीडिंग करते हैं अच्छे से, ठीक है।
Physical world. The word science originated from the Latin verb scientia, meaning to know. The Sanskrit word vision and the Arabic word ilm convey similar meaning, namely knowledge. Science is a systematic attempt to understand natural phenomena in as much detail and depth as possible and use the knowledge so gained to predict, modify, and control phenomena. The scientific method involves several interconnected steps, systematic observation, control experiments, qualitative and quantitative reasoning, mathematical modeling, prediction and verification or falsification of theories. No final theory in science and no unquestioned authority among scientists. Johannes Kepler, 1573 to 1630, examined the extensive data on planetary motion collected by Tycho Brahe, 1546 to 1601. The planetary circular orbits in heliocentric theory, Sun at the center of the solar system, imagined by Nicholas Copernicus, 1473 to 1543. Newtonian mechanics could not explain some of the most basic features of atomic phenomena, except wave picture of light failed to explain the photoelectric effect. Quantum mechanics to the study with atomic and molecular phenomena. Experiment of scattering of alpha particle by gold foil in 1911 by Ernest Rutherford, 1871 to 1937, established the nuclear model of the atom. Quantum theory of hydrogen atom given by Niels Bohr, 1885 to 1962 in 1913. Antiparticle was first introduced theoretically by Paul Dirac, 1902 to 1984 in 1930, and confirmed 2 years later by the experimentation discovery of positron anti-electron by Carl Anderson. Physics is basic discipline in the category of natural science, which also include other disciplines like chemistry and biology. Physics word comes from Greek words meaning nature. Its Sanskrit equivalent is bhautiki, that is used to refer to the study of the physical world. Physics as a study of the basic laws of nature and their manifestation in different natural phenomena. Two principles thrust in physics: unification and reduction. The law of gravitation given by Newton describes the fall of an apple to the ground, the motion of the moon around the sun. The law of electromagnetism, Maxwell equation, governed all electric and magnetic phenomena. Properties of a bigger, more complex system from the properties in interaction of its constituent simpler part. This approach is called reductionism and is at the heart of physics. Example: the subject of thermodynamics. Bulk system in terms of macroscopic quantities such as temperature, internal energy, entropy, etc. Topic: scope and excitement of physics. Two domains of interest: macroscopic and microscopic. The macroscopic domain include phenomena at the laboratory, terrestrial, and astronomical scale. The microscopic domain include atomic and molecular and nuclear phenomena. Classical physics deals mainly with macroscopic phenomena and include subjects like mechanics, electrodynamics, optics, and thermodynamics. Mechanics, founded on Newton's law of motion and the law of gravitation, is concerned with the motion or equilibrium of particles, rigid and deformable bodies, and general system of particles. Electrodynamics deals with the electric and magnetic phenomena associated with the charged and magnetic body. It's a basic law were given by Coulomb's, Oersted, Ampere, and Faraday. Maxwell motion of a current carrying conductor in magnetic field, the response of a circuit to an AC voltage signal, the working of an antenna, the propagation of radio wave in the ionosphere, etc. are problems of electrodynamics. Optics deals with the phenomena involving light, the working of telescope and microscope, color exhibit by thin film, etc. Thermodynamics, in contrast to mechanics, does not deal with the motion of bodies as a whole. It deals with the system in microscopic equilibrium and is concerned with in क्या है elongs in internal energy, temperature, entropy, etc. of a system through external work and transfer of heat. The microscopic domain of physics deals with the constitution and the structure of matter at a minute scale of atoms and nuclei, and even lower scale of length, and their interaction with the different probes, such as electrons, protons, and other elementary particles. At the very small scale of length 10 the power minus 14 meter, or even less, involving electron, protons, etc. Length scale by the speed of light 10 the power minus 22 second to 10 the power 80 second. The domain intermediate between macroscopic and microscopic, the so-called mesoscopic physics, dealing with a few tens and hundred of atoms, has emerged as an exciting field of research. Topic: physics, technology, and society. In 1938, Hahn and Noether discovered the phenomena of neutron-induced fusion of uranium, which would serve as the basis of nuclear power reactor and nuclear weapons. The silicon chips that triggered the computer revolution in the last 3 decades of the 20th century. Physics is the study of nature and natural phenomena. Physicists try to discover the rules that are operating in nature on the basis of observation, experimentation, and analysis. Some physicists from different countries of the world and their major contribution. Name: major contribution, discovery, country of origin. Archimedes, principle of buoyancy, principle of labor, Greeks. Galileo Galilei, law of inertia, Italy. Christian Heisenberg, Christian Heisen. Christian Heisen, wave theory of light, Holland. Isaac Newton, universal law of gravitation, law of motion, reflecting telescope, UK. Michael Faraday, law of electromagnetic induction, UK. James Clerk Maxwell, electromagnetic theory, light and electromagnetic wave, UK. Heinrich Rudolf Hertz, Generation of electromagnetic wave, Germany. J.C. Bose, Jagdish Chandra Bose. Ultra short radio wave, India. W.K. Roentgen, X-rays, Germany. J.J. Thomson, electron, UK. Marie Curie, discovery of radium and polonium, study on natural radioactivity, Poland. Albert Einstein, explanation of photoelectric effect, theory of relativity, Germany. Names major contribution, discovery, countries of origin. Victor Francis Hess, cosmic radiation, Australia. R. A. Millikan, measurement of electric charge, USA. Ernest Rutherford, nuclear model of atom, New Zealand. Niels Bohr, quantum model of hydrogen atom, Denmark. C. V. Raman, inelastic scattering of light by molecules, India. Louis Victor de Broglie, wave nature of matter, France. M. N. Saha, thermal ionization, India. S. N. Bose, quantum statics, India. Wolfgang Pauli, exclusion principles, Australia. Enrico Fermi, controlled nuclear fission, Italy. Werner Heisenberg, quantum mechanics, uncertainty principle, Germany. Paul Dirac, relativistic theory of electron quantum statics, UK. Edwin Hubble, expanding universe, USA. Ernest Orlando Lawrence, cyclotron, USA. Names major contribution, discovery, country of origin. James Chadwick, neutron, UK. Hideki Yukawa, theory of nuclear force, Japan. Homi Jahangir Bhabha, cascade process of cosmic radiation, India. Lev Davidovich Landau, theory of condensed matter, liquid helium, Russia. Yes, Chandrasekhar, limit, structure and evolution of star, India. John Bardeen, transistors, theory of superconductivity, USA. C.S. Towns, major laser, USA. Abdus Salam, unification of weak and electromagnetic interaction, Pakistan. Topic: fundamental force in nature. The correct notation of force was arrived at by Isaac Newton in his famous law of motion, gravitational attraction between two bodies. Macroscopic world bases the gravitational force, several kinds of force, muscular force, contact force between bodies, frictions, which is also as contact force parallel to the surface in the contact. The forces external by compressed of elongated spring and taut string and rope tension. The force of buoyancy and viscous force when solid are contact with fluid. The force due to pressure of a fluid. The force due to the surface tension of a liquid, and so on. In the microscopic domain, again, we have electric and magnetic force, nuclear force involving proton and neutron, intraatomic and intermolecular force, etc. Small number of fundamental forces in nature. Example: elastic spring force arise due to the net attraction repulsion between the neighboring atoms to the spring when the spring elongated compressed. Unbalanced sum of electric force between the charge constituent of the atom. The laws for derived forces such as spring force frictions are not independent of the law of fundamental force in nature. Four fundamental force in nature: gravitational force, electromagnetic force, strong nuclear force, weak nuclear force. Gravitational force. The gravitational force is the force of natural attraction between any two objects by virtue of their mass. It is universal force. All objects on the earth experience the force of gravity due to the earth. Gravity governed the motion of the moon and artificial satellite around the earth, motion of the earth and planet around the sun, and of course the motion of the body falling to the earth. Formation and evolution of star galaxies and galactic clusters. Electromagnetic force is the force between charge particles. Coulomb's law: attractive for unlike charge and repulsive for like charge. Charge in motion produce magnetic effect, and a magnetic field give rise to a force on a moving charge. Electric and magnetic effect are in general inseparable, hence the name electromagnetic force. The electromagnetic force is so much stronger than the gravitational force. Macroscopic force like tension, friction, normal force, springs force, etc. Gravity is always attractive, while electromagnetic force can be attractive or repulsion. Attractive and repulsion. ठीक है. Matter is mostly electrically neutral. Net charge is zero. Strong nuclear force. The strong nuclear force binds proton and neutron in a nucleus. The strong nuclear force is the strongest of the fundamental force, about 100 times the electromagnetic force in strength. Strong nuclear force charge independent and acts equally between a proton and protons, a neutrons and neutron, and a proton and a neutron. Protons and neutrons are built out of still more elementary constituent called quarks. Weak nuclear force. The weak nuclear force appears only in certain nuclear forces, such as the beta decay of a nucleus between the nucleus emitted and electron and an uncharged particle body, neutrino. The weak nuclear force is not as weak as gravitational force, but much weaker than the strong nuclear and electromagnetic force. Topic: toward unification of forces. Newton unified terrestrial and celestial domain under a common law of gravitation. Maxwell unified electromagnetism and optics with discovery that light is an electromagnetic wave. The electromagnetic and the weak nuclear force have now been unified and are seen as aspects of a single electro-weak force. The electro-weak and the strong force, and even to unified the gravitational force with the rest of the fundamental forces. Topic: nature of physical laws. For motion under an external conservation force, the total mechanical energy, the sum of kinetic and potential energy of a body, is a constant. The total energy of the system stored plus the surrounding remain unchanged. the total energy of the universe, the most ideal isolated system possible, is believed to remain unchanged. Einstein's theory of relativity in the law of conservation of mass was regarded as another basic conservation law of nature is equal to mc square. Energy absorbing endothermic reaction and appears as a heat exothermic reaction or releasing of energy exothermic reaction. According to Einstein theory, mass m is equivalent to energy E given by the relation E is equal to mc square, where c is the speed of light in a vacuum. In a nuclear force, mass gets conserved to energy or vice versa. This is the energy which is released in a nuclear power generation and nuclear explosions. Energy is scalar quantity. The conservation law of energy and momentum of beta decay, Wolfgang Pauli 1900 to 1958 correctly predicted in 1931 the existence of a new particles now called neutrino emitted in beta decay along with the electron. The acceleration due to gravity at the moon is 1/6 that at the earth, but the law of gravitation is the sum both on the moon and the earth. Topic: Conservation law in physics. Conservation of energy, momentum, angular momentum, charge, etc. Some of the conserved quantity are called spin, baryon number, strongness, hypercharge, etc. A conservation law is a hypothesis based on observation and experiments. Remember, remember that a conservation law cannot be proved. Topic summary. Four fundamental forces in nature. First, gravitational force. Second, electromagnetic force. Third, strong nuclear force. Four, weak nuclear force. General conservation law in nature include the law of conservation of mass, energy, linear momentum, angular momentum, charge parity, etc. Link between technology and physics. Technology, scientific principles. Steam engine, law of thermodynamics. Nuclear reactor, controlled nuclear fusion. Radio and television, generation, propagation and detection of electromagnetic wave. Computers, digital logic, laser, light amplification by stimulated emission of radiation. Production of ultra high magnetic field, superconductivity. rocket pro- rocket propulsion, Newton's law of motion. Electric generator, Faraday's law of electromagnetic induction. Hydroelectric power, conservation of gravitational potential energy into electrical energy. Aeroplane, Bernoulli principles in fluid dynamics. Particle accelerators, motion of charged particle in electromagnetic field. Sonar, reflection of ultrasonic wave. Optical fiber, total internal reflection of light. Non-reflecting coating. Thin film optical interference. Electron microscope, wave nature of electrons. Photocell, photoelectric effect. Fusion test reactor, tokamak, magnetic confinement of plasma. Giant meter wave radio telescope, GMRT, detection of cosmic radio wave. Bose-Einstein condensate, trapping and cooling of atom by laser beams and magnetic field. Fundamental force of nature. Fundamental forces of nature. Name, relative strength, range, operates among. Gravitational force 10 the power minus 39, range infinite, all objects in the universe. Weak nuclear force 10 the power minus 13, very short subnuclear size 10 the power minus 16 meter. Some elementary particles, particularly electron and neutrino. Electromagnetic force 10 the power minus 2, infinite. Charged particles. Strong nuclear force 1. Short nuclear size 10 the power minus 15 meter. Nucleons heavier elementary particles. Progress in unification of different force domain in nature. Name of the physicist, year achievement in unification. Isaac Newton, 1687. Unified celestial and terrestrial mechanics showed that the sun law of motion and the law of gravitation apply to both the domain. Hence, Christian Ostwald, Michael Faraday, 1820 to 1830, show that electric and magnetic phenomena are inseparable aspects of a unified domain electromagnetism. James Clerk Maxwell, 1873, unified electricity, magnetism, and optics show that light is an electromagnetic wave. Sheldon Glasgow, Abdus Salam, Steven Weinberg, 1979, so that the weak nuclear force and the electromagnetic force could be viewed as different aspects of a single electro-weak forces. Carlo Rubia, Simon van der Meer, 1984, verified experimentally the prediction of the theory of electro-weak force. Albert Einstein, 1879 to 1955, born in Ulm, Germany in 1879. The publication of 3 path-breaking papers in 1905. First paper, the notation of light quanta, now called photons, and used it to explain the feature of photoelectric effect. Second paper, theory of Brownian motion, that was confirmed experimentally. Third paper, the special theory of relativity, that made Einstein a legend in his owned lifetime. Mass energy equivalence inserted in his famous equation is equal to mc square. The general theory of relativity, which is the modern theory of gravitation, introduced in an alternative derivation of Planck's black body radiation law. Satyendra Nath Bose, 1894 to 1974. Satyendra Nath Bose, born in Calcutta in 1894. In 1916, as a lecturer in physics in Calcutta University. 5 years later, he joined Decca University. Bose gave a new derivation of Planck's law, treating radiation as a gas of photons and employing a new statistical method of counting of the photon states. New Bose-Einstein statistics was applicable to particles with integer spins, and a new quantum statistics, Fermi-Dirac statistics, was needed for particles with half-integer spin, satisfying Pauli's exclusion principle. Particles with integer spins are now known as boson, in honor of Bose, a new state of matter in a dilute gas of ultra-cold alkali atoms. The Bose-Einstein condensate. Sir C.V. Raman, 1888 to 1970. Chandrasekhar Venkata Raman was born on 7 November 1888 in Thiruvannakkal. He graduated from Presidency College, Madras. Indian Association for Cultivation of Science, founded by Dr. Mahendra Lal Sirkar. In 1917, he was offered a professorship at Calcutta University. In 1924, he was elected Fellow of the Royal Society of London and received a Nobel Prize in Physics. In 1930, for his discovery now known as Raman effect. Raman effect deals with scattering of light by molecules of a medium when they are excited to vibrational energy levels. At Bangalore, first at Indian Institute of Science and then at Raman Research Institute.
है गाइस, तो अभी अभी हम लोगों ने एनसीईआरटी नोट्स कंप्लीट कर लिए हैं, ठीक है। फर्स्ट चैप्टर का फिजिकल वर्ल्ड, फिजिक्स का पहला चैप्टर फिजिकल वर्ल्ड का नोट्स है, जो हमने हैंड राइटिंग अपने खुद से हाथों से लिखा है, ठीक है। करीब बहुत मेहनत लगा था यार लिखने में, तो हमने एनसीईआरटी में से देख लिखा था, जो मेन पॉइंट है जो नीट में आ सकते हैं, ठीक है। तो उनको हमने इन नोट्स में लिखा है, ठीक है। पहला चैप्टर फिजिकल वर्ल्ड ख़त्म हो गया, ठीक है। फिजिकल वर्ल्ड ख़त्म हो गया। अब सेकंड चैप्टर यूनिट्स एंड मेजरमेंट करेंगे, लेकिन उससे पहले हम करेंगे क्या बोलते हैं एक्सरसाइज, जो एनसीईआरटी में एक्सरसाइज रहता है उसको करेंगे, ठीक है। तो चलो एक्सरसाइज करते हैं।